I talk about alpha power sums on symmetric cones. I have one announcement. This program misprint hyphen power sums only written hyphen power sums, but alpha insert this booklet. I talk about this outline. So, generalized means knowns. If A and B are positive definite matrices, isometric mean of A and B is half A plus B, and geometric mean is this. Harmonic mean is like this, and alpha power mean is like this. Alpha power mean is on information geometric books or a paper written by Dr. Ohara. If geometric mean for scalars, the root A times B.
No, what does it mean? Because A, B is not symmetric.
Symmetric. This case is for scalars. These are A and B are matrices. These are scalars. About weighted mean like this. Interpolation for alpha power mean is defined by this. As alpha not zero, this. The case of alpha equals 0 like this. S parameter is geodesic 6 parameter for alpha geodesic 6 on a symmetric cone.
So again, this is not symmetric. A to the power 1 minus S is symmetric. B to the power S is symmetric, but the product is not.
If Jordan algebras product, use Jordan algebras product defined this. The next, I talk about generalized sum. These sums are defined by me. Arithmetic sum, this is well known, A plus B. Alpha parameter is defined next slide. Zero power sum is defined as this. This corresponded mean of A and B. A parallel sum is well known. The alpha power sum here defined by this. So alpha parameter uses this or this. If A and B positive definite matrices, this. If A and B are scalars, this equation holds. If A and B are elements of symmetric cone, the alpha power sum is defined by this equation. Function f is an operator monotone function on these if alpha power mean, the case of alpha power mean, f operator monotone function f is defined by this. This fact is well known fact. So, if alpha equals 0, alpha power mean is if A and B scalars, root A times B. If we define the sum by this is omitted half. Then this is not defined. This is well defined. But alpha power mean defined by this converges. Alpha power sum have these properties. Like me, power sum holds this inequality. And about coordinate, this part coincides sum of primary coordinates. Primary means in information geometric concept. This part is alpha coordinates of sum for primary coordinates. And this part is sum of alpha coordinates. About weighted sum interpolation is like this. 1 minus s used here and here, and added to alpha in this. For s is 0 or half or 1, this equation holds. S is middle point or divided point of 2 alpha A and 2 alpha B, not A, B. If n elements of alpha power sums of n elements like this. if case of scalars. If elements A1 to An are symmetric cones, alpha power sums of n elements defined like this. I think about the applications alpha power sums. The well-known facts the series circuits of R1 and R2 and R3. The synthetic resistance is simple sum, arithmetic sum. And parallel circuits are of R1, R2, R3. In this case, the synthetic resistance is parallel sum of these resistance. This is one problem. How circuits between 1 and 2, between arithmetic sum and parallel sum. If this resistance can realization of alpha power sums. This is resistance Rj. J is 1 to n. Cut slice Rj. When cross-sectional areas, these values. These values, sum of these values is 1. Length is Rj. If alpha is 1, this image we have. And alpha is not always 1, and alpha is not always minus 1. Between 1 and minus 1, the resistance is defined this. Cross-sectional areas and length is variated as this. And connected cutted resistance like this. If alpha is 1, connected resistance is a series circuit, and alpha minus 1 connected circuit makes parallel circuits. Then synthetic resistance is alpha power sum. Alpha for fixed alpha power sum is synthetic resistance. But other generalized sums are defined. The dual alpha power sum is defined like this. This define is dual alpha coordinates is used, and this define and this define is exist. And last, I showed this figure. This graph is one alpha power sum of 1 and t. T is this, and alpha power sum value is from 0 and 1.8. If alpha is 1 and minus 1 to 0, monotone increasing, but alpha is 0 to 1, no monotone increasing on t. His value is a small value. I talked about general sums and series parallel circuits, but other applications is not defined. Thank you. That's all.
Are there any questions?
I would like to make a little comment about AB. When you write AB, you mean the Jordan products of the matrices, not the ordinary product. That means her AB is ordinary AB plus BA divided by 2, and then it becomes symmetric and correct.
Any other question or comment? Okay, we can stop here. Again, any questions?
Okay.